Good morning everyone. I am D. Sengotian, Assistant Professor of Physics, SNS College of Technology, Coimbatore. Today we are going to see about basic terms and definitions involved in magnetism, origin of the magnetic moment, classification of the magnetic materials, domain theory of ferromagnetism and the energies involved in it, crystallisis on the basis of domain theory and ferrites. So magnetic materials basic terms and definitions. The first title is magnetic dipoles, a system consisting of two equal and opposite poles separated by a small distance. Then the dipole moment, magnetic moment associated with the magnetic dipole or magnet is the product of pole strength and length of the magnet. The next topic is magnetic field, the space around the magnet or the current carrying conductor where the magnetic effect is felt. The next, magnetic lines of force, it is nothing but magnetic field is assumed to consist of lines of magnetic forces. It is defined as continuous curve in the magnetic field. And the magnetic flux, the bunch of group of magnetic lines of forces are called magnetic flux. And the flux density or magnetic index, and the number of magnetic lines of force passing through the unit area of cross section. The next, magnetic field intensity, the force experienced by a unit north pole at that point placed in a magnetic field. Then next topic is magnetization or intensity of magnetization. It is the process of converting non-magnetic materials into magnetic materials, or the magnetic moment or dipole moment per unit volume. Then the magnetic susceptibility, the ratio between intensity of magnetization I and magnetic field intensity. So phi m equal to I by h. And next, magnetic permeability mu, the ratio between magnetic index and B and magnetic field intensity h. So mu equal to P by h. So next important topic, classification of magnetic materials. Basically magnetic materials having two types of classifications. First one is not having permanent magnetic moment. The second one is having permanent magnetic moment. So example for not having permanent magnetic moment, diamagnetic materials. Then having permanent magnetic moment, paramagnetism and ferromagnetism. Then the ferromagnetism, antiferromagnetism and ferrites. So the first we are going to see about diamagnetic materials. So the diagram shows that in the first diagram h equal to 0, the applied magnetic field equal to 0. Then the second diagram, all the electrons will align perpendicular to the applied field direction h. Then the diamagnetic materials weak magnetization in the direction opposite to the external field. Properties of diamagnetism, no permanent dipole moment, refer the magnetic lines of forces. The negative susceptibility, permeability is less than 1. Susceptibility is independent on temperature and on magnetic field strength. So next, the properties of paramagnetic materials. So the diagram shows that the first diagram h equal to 0, all the electrons in the random direction. Then the second diagram shows that almost all the electrons will align parallel to the applied field direction. Properties of paramagnetism, attract the magnetic lines of forces. Then the positive susceptibility, permeability is slightly more than 1. Susceptibility is independent of temperature. Then the last property, last important magnetic materials, that is ferromagnetic materials. The material which acquire the very strong magnetism in the same direction as that of an external magnetic field. The first diagram shows that h equal to 0. Then the second diagram, almost all the electrons will align parallel to the applied field direction. The properties of ferromagnetism possess permanent dipole moment, attract the magnetic field strongly. Then the permeability is more than 1. Then the spontaneous magnetization. Then susceptibility is positive and it is dependent on temperature given by Curie-West law. So based on the properties of ferromagnetism, these materials divide as two types of very strong magnetic materials. For example, soft and hard magnetic materials. So soft magnetic materials easily magnetize and demagnetize. Hard magnetic materials difficult to magnetize and demagnetize. So the diagram shows that the difference between soft and hard magnetism. So difference between soft and hard magnetic materials. So soft magnetic materials is easily magnetized and demagnetized, then difficult to magnetize, demagnetize for hard magnetism. Then crystalline slope is very narrow. Then crystalline slope is very broad area for hard magnetic materials. Then loop area is very less for soft magnetism. Then loop area is very high for hard magnetism. Then susceptibility or permeability is very high for soft magnetism. Then very low for hard magnetism. Reductivity, coercivity are very small for soft magnetism. Then very high for hard magnetism. Then eddy current loss. Then examples for soft and hard magnetic materials, and finally applications of soft and hard magnetic materials.